Hello guys, you're welcome back to Structures Pro. In our previous classes, we did model of circular beams, curved beams. Yes, we also did the offset of beams. The normal offset we do in AutoCAD. We also did here in Staad.Pro to offset beams, which made this slab to flush with the beam. Yeah, the normal Staad.Pro model. After adding plates, you will see that your beam will project upward and downward. The slab will just be at the middle of the beam. Yeah, but we need to offset the beam downwards. Yeah, but if you don't model your slab, there's no need of disturbing your head about offsetting beams and the rest of them. Like I told you before in our previous class, I don't really like modeling my slab. I just add the slab load to the beam. Yeah. In today's class, we'll be doing plate meshing. We mesh these slabs. Of course, once you model your slab, you must mesh it. Yes. If you don't mesh it, the load on slabs, that slab self weight, and the life load you apply on slabs will not be transferred to the beam. It will just be transferred straight to the columns, which is not the ideal thing. So the right convention is that the loads on slab will be transferred to the beams and the beams to columns. That's the right convention. Like in structural design, if you are doing manual design of structural members, you first load your slab, by panels, and you design the slab itself, then transfer the loads on the slab to the beam. The load you transfer to the beam from the slab is what you use to do beam analysis. Yes, to get your maximum moment and shear forces. So when you get those maximum moments and shear forces, you can now design for your beam, then transfer the load from that beam to column. That's the process. And from column to foundation. So now, but if you just like we model this plate now, if you don't mesh it, the load will just be transferred directly to the columns through the four edges to the columns and will not be transferred to the beam. And again, when that happens, the effect is your beam will not be carrying the load that you're supposed to carry. You get, and when you are done with your design, the beam that's supposed to fail will definitely pass because the load did not pass through it. It will definitely pass, and you now be thinking that all your members has passed. But when you don't go and do your construction, you start seeing cracks and maybe the building will collapse. So it's very, very necessary. So if you model your slab, you must mesh it. Meshing is kind of breaking the slabs in cells, creating a way for the load to be transferred to the beam first before getting to the column. That's what we'll be doing in this lesson. We learn how to mesh our slabs. Yes. So that's that. So it's necessary to mesh your slab, but if you don't want to mesh your slab, you don't want to pass this through the stress of meshing slab, offsetting beams, you can just model your beams and forget about the plates. Then you add the load. In Staad.Pro, we have under load application, you have area load and floor loads. So if you use floor load, you can just apply floor load on your beams, and you just see it as an envelope. The way it will be shared, the software shares it to the beams. So you physically don't need to model it. Or some persons would like to model their slab so that in 3D view you will see everything just as you are seeing this one. When you see this triangular panel, it looks fine, and so people like aesthetics. Yeah. So even in RCDC, when we do our member designs and the provision of reinforcement, RCDC doesn't require physical model of slabs. So once you have your beam layout, RCDC panels your slab using the beam layout. So you don't need to inside RCDC you have to now impute the loads on the slab and the thickness of the slab and the properties of the slab there. So you don't need to model it, but if you must model it, then you must mesh it. So let us dive into what we have today. So today's class is to mesh. We need to just mesh the the plate. But before we do that, we need to this offset, we need to delete it. We don't mesh a plate that we have offset the beam. It will disfigure the whole structure. So the process is you don't offset anything after before meshing. So after meshing, you can offset. Like this beam that I've offset downward, I need to take it back to normal. Then after meshing, I can offset. So we just delete the offset parameter, which is this one. That's good. Let's go back to 3D. Do not watch that video where I did offset of beams. I will say you go to my channel and look for that video. I think it's my last class. Just check for it. Offset of beams. You see it there. So as I have deleted it, see the beam it extends upward and still drops downward. So the slab is just at the middle of the beam. So that's how Staad.Pro models structures. It places member center to center. Yeah, so now we can now mesh. Then if we mesh, if we still want to offset our beam downwards, then you can do that after meshing. So for us to mesh, we go to let's select the plate we want to mesh. I will activate plate cursor. Select all the plates at this level. I will view only selected. Display the ISO. So these are my plates now. Then go back to geometry, click on generate mesh, but before then I have to select a plate there. Let me select this one, generate mesh, and plate mesh. Yeah, quadrilateral meshing. So this, you have the length of the panel I selected. You have 4 meters by 3 meters. So the length for the 4 meters will be divided by 10. That's this division 10. The side of 3 meters will also be divided by 10. So you can reduce this thing. Let me use 6. You can reduce it or increase it anyone. 6. Then you click apply. Then if you want it to be in triangular form, you can click triangular. Instead of quadrilateral, choose triangular. Click apply. So the meshing will be in triangular form. So if I choose another one, create mesh, then quadrilateral meshing, I'll still choose 6, 6. I will leave this one as quadrilateral so that you see triangular, see quadrilateral, so it's alright. So now I chose the same number of division for the first and the second because I want these nodes, the point of division to be the same for the two panels. Yes, you have this place is the same thing because they are 1, 2, 3, 4, 5, 6. So if I do it differently, it's going to split my beam, in very small portions that I don't like. So let me just use another one as an example. I'm going to choose a different division number. So you see the difference. If I still put 8 here, 8 here, 8 here, 8 here, they will not correspond and it will not be fine. So see this place now. So this one divided by 8 and this side by 6. So you see all these small, my beam will be cut like that. All these small portions. So it's always good to, if you are dividing by 6, just maintain it, especially when the panels have equal distance. So I'm going to undo this. Yes, so and mesh again, plate mesh. For the lateral, I'll maintain the 6 which I started with. Apply. So that's that. That's how we mesh every other one after the other. You can still select everything and mesh at once. It's possible. It's possible. 6, 6, 6, 6. It's alright. Okay, let me do this one. Let me use this as my last. I also maintain the same division. That's good. So you can mesh the rest. This is just to show you simply how to mesh a plate. Okay, let me go to view whole structure. You go to the 3-dimension. Now view. You see my meshed plate. Yeah. So the same way you can mesh others the same way. Okay, we'll end here today. If you are yet to subscribe to my channel, I will beg you to do that immediately. Subscribe, share, recommend us to your course mates and your colleague in the office. Thank you as you do that. See you next time.